Hi, my name is Scott from the Economics Tutoring Center, and today we're going to be doing some example problems with the standard normal distribution. So make sure to check my notation and language use with your professor because it may vary. Okay, so we're going to jump right into our first example problem. It says here that suppose that coffee prices are normally distributed with a mean of $4 and a standard deviation of $1.52. What's the probability of randomly selecting a coffee that costs less than $2.50? So let's say we let the random variable x stand for coffee prices, and we know that x is normally distributed because it tells us that in the question. But to calculate the probability of a particular x value, we need to standardize that normal variable, and usually that's called getting the z-score or something along those lines. So if you recall, the z-score for a particular value of x is you take the x value, you subtract the mean of whatever x's distribution is, and you divide by the standard deviation. That gives you your z-score. So in this example, so our x value is 250 because we want the probability related to $2.50. We subtract the mean of $4, which is here, and we divide by the standard deviation of 152. And if you put that in your calculator, you'll find that the z-score is approximately 0.987. But that's not a probability. That's a z-score, and they're two very different things. So how we find the probability is we look at, so the probability that x is less than 250 is the same as the probability that its standardized value z is less than 0.987, because that's a z-score. So if you look at the z-table or use an online calculator or your graphing calculator or something, you'll find that the probability of this particular value is 0.16186. So that's our final answer for this question. Now we have another example. We have the same information here about the mean and standard deviation of coffee prices. And we're still going to let the random variable x stand for coffee prices. But now we want to know the probability of a coffee being more than $4.25. So again, we start by standardizing this value. So remember, to standardize one specific x value, we take the x value, we subtract the mean, divide by standard deviation. So in this case, that's $4.25 minus $4, which is the mean, divide by standard deviation of 152. If you put that in your calculator, you'll get a z-score of approximately 0.164. And again, that's not our final answer. The z-score is not a probability. But to calculate the probability, so the probability that x is greater than, because we want more than in the question, greater than 425, it's the same as the probability that its standardized value is greater than our z-score, 1.1 or 0.164. And if you try to use the z-table, you'll run into a problem because we have this greater than sign in our probability, and the z-table gives you probabilities that are less than a particular value. So what we can do, though, is note that this probability is equal to 1 minus the probability that z is less than or equal to 0.164. Then if you look up this probability in this probability here on the z-table or online using a calculator, You subtract that from 1 and you'll get approximately 0.43468. And that is our final answer. It's the probability that a random coffee costs more than $4.25. And note that because this value, $4.25, is above the mean of $4, the probability of a coffee being greater than $4.25 has to be less than 1/2. Because in our normal distribution, it looks like this. Here's our mean of $4. This probability here is 1/2, and the probability we just calculated is from $4.25 and above. So that's why it's less than 1/2. But that's how you calculate the probabilities of using the standard normal distribution. So that's all we have today about the standard normal distribution. I hope it helped, and if you have any further questions, please come into the tutoring center or ask your professor.